Hello, geodesy lover. In this section, we are going to cover the North American datum of 1927 and the North American datum of 1983. Please remember that NAD27 and NAD83 are both horizontal datums, and that the modern space-based NAD83 CSRS, on the other hand, is a fully three-dimensional system whose realization is kept by means of space-based geodetic measurements, notably GNSS. The North American datum of 1927 is a geodetic system, and because it was materialized by means of terrestrial and astronomical observations, it is treated in the terminology that we presented before as a classical coordinate system, and is treated as non-geocentric because, as we have seen before, its origin is offset from the center of mass of the Earth by hundreds of meters. It is based on classical terrestrial techniques, mostly triangulations. The origin of the coordinate system is a marker located in Meads Ranch, Kansas, in the US. We could call that the datum point. And several astronomically determined Laplace azimuths were distributed throughout the network to maintain the orientation over the network. NAD27 uses the ellipsoid of Clark, 1866, which is obviously concentric with the origin of the geodetic Cartesian coordinate system. NAD27 came to be with the existing data at the time based on the computational procedures of the time. With time, demands of various nature led to the expansion of the network based on increasingly more accurate surveying methods and methodologies. The expanding network, as well as resurveys with more accurate terrestrial equipment, turned apparent distortions in the network. Another problem affecting the station coordinates was the physical motion of its markers under the effects of crustal deformations, such as earthquakes. The necessity of improvements became more and more clear with the passing decades. A series of meetings involving Canadian and American geodesists started to take place in the 1980s to discuss how to improve NAD27, including a meeting hosted by the then Department of Surveying Engineering at the Fredericton campus of the University of New Brunswick. The methodological approach to build a new North American datum is a result of these efforts. The North American datum of 1983 was conceived to be a geocentric coordinate system. It resulted from the simultaneous least squares adjustment of 1.78 million terrestrial observations all around North America, connected through Doppler Navy navigation satellite system and VLBI observations. NAD83 was defined to be compatible with the BIH terrestrial system, the BTS-84, which can be considered as a precursor of the ITRS. The three-dimensional origin of the North American datum of 1983 was chosen to be concentric with the GRS-80 ellipsoid. Even though the NAD83 was idealized to be a geocentric coordinate system, it is known today that its origin is offset from the center of mass of the Earth by around 2 meters. The relation between NAD83 and NAD27 is not a simple 7-parameter transformation. There are too many non-uniform and at times very large distortions that require to be modeled through the network. The approach chosen was to use multiple regression expressions, which were developed for this purpose and incorporated into a program called NTV2, where NT stands for National Transformation. This is the approach used, and it has been incorporated into various cartographic and GIS computer packages. It should be mentioned that even though the federal geodetic agencies of both Canada and the US worked in close collaboration, a few developments of the NAD83 in these two countries have taken different paths. The unification of NAD83 in Canada and in the US was done by defining a relationship with the ITRF-96. This realization is denoted NAD83 CSRS in Canada and NAD83 NSRS in the US. This relationship was based in transformations related to the reference epoch 1997.0. We can see from the parameters below that the translations indicate the offset between both frames to be at the order of 2 meters, which would be the order of magnitude away from the geocenter if we consider the ITRF-96 to be offset away from the geocenter by a few millimeters. No scale differential is used, and rotations are given along with their time derivatives, all of them computed from the reference epoch of 1997. Please note that these rotations are defined as clockwise rotations to follow the IRS specifications. NAD83 CSRS is maintained by space geodetic techniques, being therefore a three-dimensional system. The relationship between NAD83 and any other ITRF is therefore possible through the ITRF-96 following the parameters as given by the IERS. In other words, we can transform coordinates expressed in NAD83 to any ITRF through the ITRF-96, even to the most current ITRF. For example, we have here the transformation parameters connecting ITRF-96 to all previous ITRFs, including their rates of change whenever applicable. A reminder that we first need to apply the incremental transformations from NAD83 to ITRF-96. The Canadian Geodetic Survey of Natural Resources Canada has a series of computer software applications available either online or for downloading, available on their website. One of such applications is a program called TRX, which allows transformations of three-dimensional geodetic coordinates between NAD83, CSRS, and any one of the ITRFs, and also between the ITRFs. TRX allows transformation of a single point or a full list of points anywhere in the world. A list of Canadian Geodetic Survey online tools is available on the link provided below. The last link directs to a very nice overview of the whole Canadian Spatial Reference System. As mentioned before, the paths followed by Canada and the US diverge here and there. A major difference is going to be caused by the adoption by the US of the North American Terrestrial Reference Frame, the NATRF 2022. This new frame will replace the North American Datum of 1983 adopted by the US, the NAD83 NSRS. The problem here is that this new realization will not be compatible with the NAD83 CSRS. It is expected that differences of up to 1.5 meters in horizontal coordinates will exist at the Canada-US border. A few references are indicated in this slide, one written in the journal Geomatica, and the other is a pamphlet made available by the Canadian Geodetic Survey. In summary, NAD27 is a classical geodetic system. NAD83 is a hybrid geodetic system. NAD83 CSRS is a modern, space-based geodetic system kept consistent with the ITRF and compatible with the US NAD83 NSRS. A new US-based North American terrestrial reference frame, NATRF 2022, is coming soon with huge displacements in the Canadian border.